Hi, welcome back to Math 111. We're going to talk about function notation, which I actually used in the last video, but I want to break it down for you. So functions are like the mathematics or the engines of mathematics. So let's suppose I've got a function, and what I'm going to do is I'm going to write an expression for the function g that multiplies a value by 3 and subtracts 7. Okay. So function notation simply gives this sequence of operations a name, and the name is g. So what I'm going to write is g, and then we need to say what variable we're going to operate on. And most frequently that's going to be x. So this reads g of x. In other words, the function g operating on the variable x. And this function takes that value, represented by x, and multiplies it by 3 and subtracts 7. So function notation is simply a shortcut way of naming and working with functions. And so now suppose I want to find the y value that corresponds with an x value, fine, corresponds with an x value of 1. Well, we know what that means. That means find y when x equals 1. And we'll go ahead and say that this is for this same function. So we know that we can say, all right, so if y equals 3x minus 7, find y when x equals 1. That means replace my x with 1 and find and crunch. Well, but we can also say that this way. We can say g of 1 equals 3 times 1 minus 7. Which means that g of 1 equals 3 minus 7 is negative 4. So what I've done is I've used function notation. And when I use function notation, the thing that comes first is the function name, that is a g. And then in parentheses is the value at which I want to operate. So in other words, the x value. And so this reads g of 1 equals 3 times, now because I replaced x on this side, I'm also going to replace x on the other side. So g of 1 equals 3 times 1 minus 7. So that means g of 1 is negative 4, which means that the point (1, negative 4) is on the graph of g. Okay? So let's do a couple more examples like this. Let's say that, so let's let f of x equal negative x squared plus 3x plus 4. This is a perfectly valid quadratic expression. We've just given it a name. We've named it f. So let's find f of negative 1. To find f of negative 1, we replace all of the x's with negative 1's. So this would be negative 1 squared plus 3 times negative 1 plus 4. And again, all of these negative 1's appear wherever an x appeared. Okay? So negative 1 squared is 1 minus 3 plus 4. That's 2. So f of negative 1 equals 2, which means that if I plug negative 1 into this function, the y value that corresponds with an x of negative 1 is 2. Let's do one more. Let's find f of 0. Again, same thing. Negative 0 squared plus 3 times 0 plus 4. That's pretty easy. That is 4. Okay. Now, sometimes things can get a little dicey. What if you're asked to find f of 2x? And you may be thinking, what the heck? Well, this isn't a big deal. We just take all the x's on the other side of the equal sign and replace them with 2x. So whatever is inside your parentheses goes everywhere we see an x. And now we crunch. So this is negative 4x squared plus 6x plus 4. And that is our answer. F of 2x simply equals negative 4x squared plus 6x plus 4. Okay? What if I've got something, what if I'm asked to find something like f of 2 plus x? No big deal. We replace all of the x's with 2 plus x. So negative 2 plus x squared plus 3 times 2 plus x plus 4. And now we do a little algebra. So 2 plus x squared is 4 plus 4x plus x squared plus 6 plus 3x plus 4. Distribute that negative sign through, and we've got negative 4 minus 4x minus x squared plus 6 plus 3x plus 4, which gives us negative x squared minus x plus 6 by the time we're all simplified. So this is f of 2 plus x. Okay? All right. Now, what though if you're asked to find 2 times f of x? Well, that's easy enough. The 2's on the outside, so you don't do anything inside. And we just distribute the 2 all the way through. Okay? All right. So that is the basics of function notation. And I think that the rest of this section in the textbook is fairly self-explanatory. There's a discussion of modeling with functions, which really means just building equations based on word problems. So I encourage you to read that section in your text. It starts on page 60. And Pay special attention to the discussion of piecewise defined functions. And let me know if you have any questions. I'll talk to you again soon.